Hello everybody, welcome to another stream. How's it all going? Hey there, Retor Ika. Welcome. How you doing, sir? So last stream, we run the entity generation script. We added the ability to the entity script. There's a C program which we can just compile and run, and it will parse a file and then print out everything it's parsed. So this file here is all being parsed. We know the types of every property, the name of every property. We know all the archetypes and all the properties within an archetype. I think what I would like to do is add this bit flag field to another one with an optional, because I was thinking about making it so we can do optional bit flags as well. That'd be pretty sweet. And we'll talk about more of those in the future, I think. Hey there, RWX. How you doing? RWXC? 99. Read, write, executable, C99. Magical. Yeah, so here's the to-do list for today. Basically, we kind of want to design the API, iterate over archetypes within an area, iterate over properties within an area, create entities, take an ID to a reference, maybe have typed IDs for entities based on archetypes, having an AOS variant, an SOA variant that gets code generated so we can test performances, and Swizzle, having a Swizzle variant as well, which allows support for SIMD. So to start things off easy, I want to take this text reader, because I think it's done a good job, and I want to put it in the core header file. So core header file, we'll just maybe go somewhere like string. Maybe not. Let's put it at the bottom. Just remember my keys. Oh, where's that? What's that key? Oh, you don't shift press it, right? Nice. Ink that. Cool. Could have just pressed ZZ there, but I didn't. Right, so this is text reader, and then in the source file, we'll drop all this in there as well. Hey, Cat Payne, how's it going? How you doing? Core.c, end of the file, drop it in there. Let's grab a header. Right, GT, then I can go text reader. Cool. So now I've just moved the text reader out of our entity generation script. So to read and write out to the standard out, is about 300 lines of code at the moment. So yeah, that's all right. It's all right. Still works. Use the C JSON library. Had trouble linking it. Learned about how to compile object files, static library.a files. But could have skipped the whole headache if I'd remembered to include the C source file. Right, yeah, single headers. Yeah. Also, you could just parse your own JSON file. That's the other way around it all. You know, just avoid libraries. Yeah. You know, a bit of JSON 5. That'll be good. No, you could do it. I believe in you. It's not too hard. Not too much work. Hey Lupo, welcome. How's it going? Doing good. I played a video game yesterday and the day before that. Played some games. I played the latest Ratchet and Clank game. You know, Rift Apart, is that it? 'Cause I haven't played that one yet. Because when I joined work, they gave it away to everyone. And I was on my probation, so I didn't get it. So I was like, ah. And I wasn't really playing games much anyway. I don't really feel like just buying a game because I probably won't complete it. But finally, they gave me PlayStation Plus Premium. They gave it everyone it. So, got a whole catalog of games I can play through now. Should have access to all the Sony titles, I think, and some Ubisoft ones as well. So I've just been enjoying Rift Apart at the moment. It's pretty good. I actually think the gameplay is good. The first set of levels in that game, they're so packed with so much stuff. Like the people in the environment, seems like they spend a lot of time just filling the levels with stuff. It's been pretty cool. Right. So entities. I think what would probably be decent is to design the iteration API first, maybe, because that's the one we're probably going to use most, and that's the one you probably want it to be the fastest, I guess. Yeah, it did come out like 3 years ago now, so it's been a while. Well, maybe we could just code gen. Should we start code gen and stuff, maybe? We code gen the arrays. So I think, yeah, no, let's talk about so what I'm thinking about doing is, so if we iterate over, yeah, so I proposed my ideas on the Discord. I was thinking about having basically like this thing like called like an entity ref, where it's a reference into the arrays, into the structure of arrays. But you only obtain this at the start of the frame, or you can convert your ID into a reference. So I thought, you know, we could make it such that every property has a getter and a setter. And the thing is, though, this is not typed as well. Yeah, I think this has got a few problems. And so if we made it a getter or a setter, we could also make it support SIMD as well by saying like get x4 and then say if the coordinate is swizzled. We can get all of the x's in the loaded into this register. And you can store them back in all in one go as well. So it won't be having direct pointers to the coordinates, so it could be swizzled. But yeah, Glorissa pointed out some problems with that. Because if you have this entity ref, it's technically referencing like 4 objects, 4 entities that live next to each other. So it kind of is a bit of a weird design. And also he suggested grouping all the swizzled data one after the other. So saying like, you know, all of your x's for 4 entities together, then all your y's for 4 entities together, and then z, and then it will repeat. All in the same array, so we don't have separate arrays for x's, y's, and z's. So it should be more cache efficient, hopefully. So yeah, I think maybe this could be like the iterator API, perhaps. I'm not sure though. Something like that. So we should really design it. Hey, Glorissa. Yeah, I'm doing good, man. Doing good. How are you? Yeah, it's on TV. Back in the days when I did not know English, I would not pay attention to game titles. Fair enough. Yeah, that's what I would have probably done as well. Some people are really into consuming content that they don't really understand too much of and learning the language through that way. I don't have the patience or time for that, really. So there is actually a PC game which looks like Ratchet and Clank because it is Ratchet and Clank. The latest one got put on PC. I think it was a year after. I don't remember the exact timeline, but maybe yeah, it was definitely a port that came later. So maybe we can have an iterator strut, which yeah, so maybe we should just design the iterator API. This would be a lot of fun. So I think we'll have like some kind of like, see, I don't even want to short it to ent because we might as well call it entity, or has anyone got like a short entity name that makes sense? Because yeah, you can have a few. I think you got like a few words that come from ent, which is like entrance, entropy, and yeah, there's quite a few maybe, but maybe they don't apply to games, so maybe shorten it to ent is okay. We'll think about it. So entity iterator or something. Let's just call it like a big old fat name. Yeah, I think there's already a library called that entity, isn't it? Look, entity. That's even longer. The entity, yeah. So I'm thinking like you probably want to iterate over like some properties, and then see the way we're doing this is so let's design the function first. You probably want to say entity iterate over all the properties in an area, say, right? So maybe, yeah. So maybe you give a point, like, could you say give a point in 3D space and then say like, give a radius, or I think it's going to be more you want to iterate over all the ones within an area, but it could be like a circular area, a boxed area. But I think we could just stick for a circular area for now. Yeah, so maybe like iterate. And then we need to be able to basically pass in like, you want to iterate the properties, right? Or over a certain set of properties. And right. So you could probably say there is a, let's get that drawing we had up in the past. This one. So if you have this entity that needs to, like, maybe there's, say, it's like a cone, right? I guess so you'd need to look at all the entities in this box and this box. Because each chunk or region is going to have its own array of entities. Its own pool of entities. So that could be like a cone. You could also have a radius. You can also probably have a box as well. So tying that into this iterate thing could be a bit nuts. Maybe yeah, maybe there's different levels of it. Yeah, so maybe you have like you can iterate around a sort of like, So you could probably get a list of regions. Yeah. Then we'll start off with this one. You'll get a list of these regions. There'll be 3D coordinates. And then any of the ones with collision shapes or whatever could be built on top of this. And yeah, that would just make programming logic a lot more easier, right? So you could say, given a list of regions, I want to see all the entities in there. And then you'll get back an iterator, which will be able to search over all the... So you also need to have kind of like a list of properties that you want to look over. And you would also want to know... Yeah, I think, because what other entity systems do when they have these iterators, which is kind of quite powerful when you iterate over different properties, is you have different operations, right? You have basically, there's an operation where you sort of like require it to exist, the other operation is that you require that it does not exist, right? So maybe exists, not exists, optionally exists. So when you iterate over when you say, hey, give me all the entities within this area, you can have these sort of rules where you say this property has to exist, this property should not exist, and so you can say, give me all the properties that don't have inventory, and that could be a way that you query and query the entity or filter them out, right? Then optional allows you to say, well, if it optionally has an inventory, then you can get ones which don't and have inventories as well. So these could probably be like bits, the high bits of the properties when we pass them in. So these could be some type of flags. So, you'd also want to pass in, when you create an iterator, all of the properties that you wish to iterate over. So you should probably code generate a property list. So yeah, this would probably be called like entity prop. Maybe I could short it to n or n. Yeah. Maybe so. So we'll code generate all these. Maybe you have like a coordinate one, right? Maybe you have like a what's another one? Health on it. And then maybe, and obviously you have a count at the end, right? So the reason why I'm thinking about lower casing them is so we could probably do some magic where we like stitch together some strings and end up getting that property there. We'll see though. So I think then you could probably pass in the properties. And then maybe you could say properties, and then maybe they could be like a property mask. So maybe you could say like define entity prop exist, and then you pass in the property, and then maybe we can like stitch on ent prop with prop, right? And then maybe this would not set, it would not do anything, right? Whereas the ones where it's like not exist and optional, as an optional property, these ones would set the high bits. So maybe we'll have like a mask, we have like an ent iter prop flags mask. This would just be up in the high bits. So maybe you say like we need 2 of them, so that's just C, isn't it? 2, 3, 4. And then you could probably just have like a not exist. not exist flag, or maybe we say flags not exist. And then we'll say something like flag optional. So that'll just be a 8 and a 4. Nice. So I think these things we could then just like or it on like that. Ent prop flag optional. Right. So these will help us define our iterator, I guess. So obviously this will need to be type def, right? So, right, we can start probably writing out some usage code, but maybe we'll add another version here. So this be like entity iterate, iterate in area, iterate area, like a radius, right? And then maybe you put in the properties that you want to search for, and then you put in like a position in space, a coordinate, then followed by a radius. Would you specify that in integers or floats? Because it is kind of gridded. Yeah, you can probably do a float like that, innit? Yeah, so then this one would call this one underneath after it does like an area check over which regions it collides with, right? So this would be pretty sweet. And then, so I guess we can try and write some usage code just to see what it will feel like. Because this is what we want to try and do, is make an API which is actually going to be decent and not just write the prototypes and think that'll do. Because I've written so many APIs and it's easy to think one is good. So here's the actual usage code, right? Test iterator. Let's just fit it in here and right. And this is C, right? So you have to put a void in there, you know? So this is where we would do our properties, right? It's kind of interesting. So you go, so maybe right, you put the coordinate and the radius in first because the properties would be like a list, and maybe see, it's a pointer which is annoying. It's going to make it hard to pass in a list of them. Now the properties, we might need to have a handful. You could probably fit them all in a couple of integers, and pack them in. 1 byte per property. And if you had a 64-bit int, you just packed it all in. Then you unpack it. You can support up to 8 properties to search over. That could work. And then you're not passing it in as a pointer. But then you have to write some magical packing code through some macros, which could be a bit hairy. But having a maximum of 8 properties, it could be possible that you want more. But I think there's ways to do it. Maybe we take the iterator as a pointer and then we can always define a list beforehand in a local. Yeah, it's always possible. So I think we can, what we'll probably do is, so if we bring these, that's the iterator, then I think, oh. So I think we'd also actually like to bring these regions, make the properties go last maybe. Whoops, I didn't delete those. All right, so this would then say return just void, and that will return void as well. So we would then probably have a macro which actually wraps this, and what this would do is make it such that we can define a much easier to use API. So we could probably declare this to be the sort of an underscore version of it. I don't know. And you pass in the iterator as a pointer. Then you pass in the coordinate and the radius, and then a variable amount of properties. So I guess we could say like properties, right? Like that. Then we can do something like this, or we define a scope. So I want to try and avoid as many macro hacks as possible. So at most, we'll probably make just a few lines, rather than sort of this macro calls that macro and does some magical things. Yeah, we kind of want to avoid as much of that craziness as possible. So I won't really mind about declaring a local array. The local array might be okay. So I have a local array of ent property, and would say we can just call it whatever we want. Hopefully, I could probably say like maybe I could say ent props array. Right, I'm probably very unlikely going to call something an EPA. So there'll be an array of these guys, and literally the variable args goes in there. So join that all up there, be nice. And then remember to backslash it. And then this one we'll just call iter, put the coordinate and the radius in there, and you take the address of EPA, and then you do core array count of EPA, so that gets the number of properties. And then that shall, and then it returns void, so we don't expect this to be used, to return a return value, so this block thing will work out okay. There is a GCC extension to essentially get what like Rust does, where you can return stuff from blocks, which is kind of cool, but it's not in C, so it's a bit dumb to try and use that. Yeah, so now this means that this API can be made like, when we try and use it, it can be made like really nice. We pass in the address of iterator that we want to instantiate, some coordinate. Say if I'm at like, 130, region 130, or maybe not region, maybe the player that I'm looking at is at, I guess, grid cell 123, and then like 580 down. Well, right, let's say like maybe 100 y, and then like 530. I wonder what, yeah, the z and the y should be, I think, Yeah, I guess we'll make it such that the x and z coordinates are, so this is x, and then this is z, and then the y is actually going physically up. But now, so we put in the radius. Say we have a radius of like 10 meters. Now this is where the fun begins. Star Wars, such a great movie. So we literally just define a list of properties that we want to search. Now, what we want to say is we want to, we say entity prop exist. So we want this property to exist, and that would be the coordinate, right? And then we say we also want to search over entities that do not have health, right? So we say not exists. Wait, do we want to not exist? Yeah, so that's a very poor example. We want to iterate over all the entities that have a coordinate property but do not have health coordinates for some reason. Very poor example, but you get the idea. And there's also an optional one as well. So now we'll create iterators to do that. We just got to figure out how we want to do this. How I want to implement that internally, I'm not sure yet. But at least we've managed to create this API, and it seems quite usable. Now we've just got to make it such that we could actually iterate. And so you could probably say like entity iterate, and pass in the iterator. So we'll just sketch out some idea of how I want to do this. And now we need a way to like take the iterator and get it to give us the next coordinate, basically, because this health thing is not one that we're going to be allowed to get. We should probably say, you know, let's add another one as an example. Let's say what were they again? Oh yeah, like a weapon. So health weapon ID. What's another one? Let's do the inventory. Okay. Is this guy AI? Maybe he's AI. Alright, so. No, the new person in chat F system. I'm not sure if this design prevents the asynchronous side fumbling overloading. Sounds quite random. So if we change this so we can have something that's a little bit more. So let's say we don't want them to have inventory for some reason, maybe, but we want them to optionally have a weapon. And so now what we need to do is have a way. I won't be able to have trailing commas, I think. That won't really work. So when we call this iterate, it will just essentially advance to the next entity. And now we have to have a way to actually get the properties out. So I think we should probably codegen some functions, and so we probably want to say entity iter prop or iterate get or coordinate get, and that's a codegen function, and it will return a typed. It can return a typed thing to be able to pass in the iterator like that, I imagine. So if the iterator doesn't support coordinate in debug builds, what we'll do is assert, right? So we'll be able to catch if it wasn't marked as being existing or optional, then it will assert. Now we have the question of what happens if we retrieve a weapon, but we didn't check if it was optional first. I guess it will just assert if it doesn't actually exist on the entity, right? Yeah, so maybe like a weapon ID, something like that. And so say if you do weapon ID get, so maybe you can query iter prop exists, maybe. You could say prop exists, and then you say ent prop. Or maybe you could just say weapon ID. Maybe it's like a macro that automatically pastes it on or something like this, right? And this, so you can then wrap. Maybe I should be careful with these macro things. I don't know. So then you could say if the property exists for this one, extract it out and operate on it there. Right. Yeah, okay. And then we probably want to obviously have ways to write back to properties as well. Do we want to mark components as writable? Is that going to make any sense? Like when you iterate over them? Like, say if I just start iterating over a, you know, all entities with these properties, does it make sense to specify I want to write to them beforehand? We're not writing an ECS system where it does all the job system-y stuff. That's done elsewhere. So that should be done through dependency systems on the jobs instead, which we can catch in other ways. Say if you have ways to set yeah, I don't think there is a limit to that. So I guess we'll just say, right, we also have ways of, you know, simply changing weapons or, you know, properties as well when we iterate. Is changing them a bad idea? Weapon ID, I don't know, gun of some kind. So you can change it change the entity you're currently iterating over. Yeah, there's not problems with that. And then we probably also want to have ways of like saying iterate we want to have a way to sort of defer delete and probably create more entities as well, but those probably get created the next frame and deleted the next frame at the beginning. But yeah, this would be, say, defer delete. Yeah, so this will just defer delete that entity that is currently iterating over. Yeah, just mark it for deletion. You'll probably want to have stuff like this. So, right, this looks pretty sensible. We could think about the SIMD API as well. Like if I wanted to add SIMD support, how would that work? But also this naming is a little bit strange, if you will, because this just says like iterator weapon ID set. You know, maybe that's okay. Iterator defer delete. It seems like you're defer deleting the iterator, but you're not. But yeah, it operates on the current entity the iterator is pointing to. If I get the current entity that's being pointed to as a reference instead, then the API could probably... Yeah, maybe we should define different things where you get back like an entity ref or something. And then maybe you could have like a SIMD. You could probably have like a wide reference, if you will, that references the next 4 entities or something. Or ref range, which does a range of entities. Yeah, because maybe if you do like SIMD, you will operate on like 4 entities at once, but maybe you only want some of those entities to be deferred deleted, right? So maybe you have a wide reference, then a mask, a range, and then a mask or something. Idea of optional properties is not very friendly for SIMD with that API, I think. Yes, that is true. So that will be the case when... Yeah, because I think that the problem with the archetype approach is that you end up having to split if... So I think the optional would be... Let's go back to that document I deleted. Still there. Right, still here. So, yeah, I think with the archetype approach, I want to try and avoid the problem where the pools of archetypes have just a few entities in it, and maybe that doesn't even fill a cache line, right? So until I know an entity has like tons and tons of or until an entity has many in a region where it makes sense to split it into an archetype, the thing would be is to use an optional field, I reckon. To have optional fields such that yeah. Yeah, optional fields such that that there won't be a waste or as much waste as if we split it up into two archetypes, distinct archetypes. I think but it should mostly be used for the case where a property is most of the time used, but very rarely not used in an archetype, if you get what I mean. You could get a chunk of entities with the optional preset and then without. Right. Right, have them aligned in such a way where, yeah. Yeah. So that's where I'll probably introduce another archetype to do that, I think, rather than having a special system for it. I think that would be sensible. But yeah, it would be a bit weird on where we need to split these entities. Hmm. Yeah. Yes, I guess you could say like a SIMD ref maybe. So it's just a group of them. And then I guess when you defer delete with a SIMD lot, you can have a mask to say which ones you want to actually delete from that. Yeah, I think that'll do it. So I guess we can design the API at least. So we want to have a way to say, right, so I think we'll just say ent. We'll keep the ent thing. So ent then we'll probably also enter ent iter. So that'll return a boolean. Right, so return true when there is something we need to, or something that we can advance to. Then we need a way to convert that into an entity reference. So we can then just say, what is the entity ref? Maybe it returns an entity ref, actually. The thing is, though, we've got to try and take these concepts and match them into how I've decided to store these entities physically in these different arrays and archetype pools. So we'll see how this maps in a second when we have the API designed. Yeah, so maybe say iterate, and then you can say iterate. There'll be a SIMD version or something, and then you get back a SIMD ref instead. Or maybe call it ref SIMD. I don't know. So you might need like a mask as well somewhere. I'm not sure. To know which, or to know how many of them are actually active. Because you might have iterated to the end of the array and only have 3 out of 4 active or something. Right, so after that, we want to make some. So these things would be codegen. So say something like you, and it's a. What am I doing, bro? So we're currently designing an API for our entity system. We designed it last stream, and we've got a custom file that we're parsing, which defines a bunch of properties and defines a bunch of archetypes. And we currently have a parser which parses that file and just prints out that data. So we're currently designing the API to try and see how we're going to code generate this entity source code, which will have all of our properties in some SOA format. So it should be more optimal to hopefully operate on thousands of entities that we've got here. We should be having maybe 73,000 entities. But we're also going to probably bin them into regions in the world and have different pools per region. So yeah, we're just at the phase of designing the usage code and how we want to use this thing, and then trying to fit it into the low-level design we have. So I'm just trying to figure out exactly what I want to code gen, basically. But yeah, that's what we're working on at the moment. Thank you. But yeah, I guess I'll give you a quick tour of the game that we got already. What was it again? It was... There we go. So this is the game we have currently. We're working on a custom renderer which basically ray traces a bunch of ellipsoids. It's got a BVH builder. So we build the BVH on GPU. And this is just a bunch of tiles that spin around and it kind of looks like water. It's got PBR. So we're currently taking a break from rendering and doing sort of the game technology side of things for now. So we're doing that for the next 8 months and building like an editor so we can make some custom models and things. So we're currently building the entity system that we're going to be using because we're going to need that for the editor as well. Yeah, so this is going to be code gen. Well, this is all going to be code gen, but this prototype is going to be code gen, whereas the other ones are kind of fixed. So this will be like entity ref coordinate get, right? And you can pass in some entity ref and get back a single coordinate. And then there'll also be a setter as well. Right, this will be code gen, which would be quite nice. So that's the value. So we can call it like value or something, I don't know, but yeah. So we would also need to say, hey, for this entity, does... So this will probably go up in this sort of section, or maybe a different section. So for this entity ref, does this property exist? And maybe you pass in the ref followed by the entity prop. Yep. So you can ask if something exists. That's for the optional ones. We can also defer delete them. So you can say defer delete. This will be deleted at the start of the next frame or the end of this frame, something like that. So defer delete. There's no way to delete it right away, I don't think. Or I could say delete deferred. So this takes in a reference. So the reference is the one which points to it directly inside the array. There's no indirection. It directly points to the entity within a particular pool. Whereas the ID would have indirection. So this one would change every frame, possibly, because entities will be shuffled around as they move between regions and as they get deleted, as other ones get deleted. You can use the fact that entities are stored in a linear manner in pools to treat iterator not as entity iter but as pool iterator. So you can just get a pool count and take base addresses from property arrays. Right. Yeah, because this is the problem I'm running into, isn't it? Where I have this reference, but then how am I going to get the reference into the right pool without doing a switch statement, isn't it? So what you're saying is there's a pool iterator, right? Yeah, so I wanted to add support for both types of iterators. I wanted to add support for iterating over archetypes and just over properties in general. Yeah, so I guess this is iterate over all archetypes with these properties. And then I guess that would just iterate over those archetypes. But yeah, that API would be a lot more easier, wouldn't it? Yeah, that would be very easy. Because I think this API is very powerful. And there's a powerful thing about ECS when they have this. But we iterate over pools, the limitation would be would have to rewrite the same. You'd have to copy paste the code and swap out to the different archetype ones as well. Yeah, I wonder how we would get this to work. The next thing to figure out. But you'd have to copy paste the for loop and then rename a few things, or maybe a lot of things, I'm not sure yet. But yeah, let's see. So I'm hoping this one would be a way to do that, but not have to rename a whole bunch. That's the hope. Let's reference get. Right, then there's obviously a weapon one as well. Something like that. So that'd be the defer delete one. All right. So that won't pass in the iterator though, that'll pass in the ref. So that would be like entref. Entref. Oh wait, hang on a minute. So I think we're getting to the point now where I'm kind of liking this design, but now we've got to figure out, is this thing actually feasible to implement? Yeah, is this thing actually possible without having some weird weird switch statements or something, you know? Can I design my data in such a way where we don't have to do that? Right, that's pretty neat. Let's save that out. Yeah, I assume that entref is going to be a generic reference. Yep, can refer to any archetype. Yep. So you probably need some way, probably macros, to get the property out of the referent. To get a property out of the reference without knowing its type. Yeah, that way you can iterate over all entities with the given property, assuming they have some kind of structure. Yeah, so I think we might have to store in the high bits, like what archetype pool this one is from, or some offset, some byte offset from the global entity pools of pools structure, where all the pools live. And then maybe that can get you to the... But then, like, how would you, like, have all of the pointers then for, like, all the... Yeah, it's difficult, isn't it? Ugh. Because they're all going to be... Where's that file? So let's get these boys and girls in here as well. And then someone will be like, oh, this is spaghetti code. I'll be like, okay. But yeah. This is... Right. So we'll probably have, like, it all live in some thing. Let's just call it entity sys. And this will probably house all of the archetypes in or something. Let's write that out. I'm not sure if this approach is more powerful than what I described because you still will be able to iterate over archetypes and other properties, but it would be less abstracted as, I guess, because current entity iter is basically iterates over pools and then over entities. Yes. Yeah, so it iterates over... Yeah. Yeah. And you'll... Right. Yeah, pools and entities, yeah. Yep. Yeah, but my concern is that say if you wanted, you'd have to repeat. Yeah, so I guess you could do two. Yeah, because my concern is you might have to duplicate the iterator loop with that approach, right? You'd have to duplicate the loops and then call different iterators on different pools. So, yeah, that's my concern. But I definitely want to support that approach, though. Because I think it would be powerful just to have that be easier. Because what I'm thinking is, like, of the pools is that has a set of flags saying what properties are stored in the pools. Yeah, probably. Maybe some form of common header or something. Yeah. Then you can iterate over the list of pools. If they store a particular property, you can care about them. Or a property you care about, then iterate it. Yeah, exactly. You could probably have all the bits all in like a contiguous array as well. The bit fields, right? Yeah, exactly. We might do something like that, but yeah, we've got to try and figure out how we're gonna. Yeah, that does sound like a good solution, but we're still got to figure out when you have an entity ref, given the fact you're inside, like this health array isn't going to be always in the same location, like the second one in. So given I've said I want to iterate over the coordinates and the weapons, how do I maintain... How do I iterate over all of those different arrays and cheaply do it when I call this iter function? Because presumably it could switch between different pools, and that could be quite hairy. But maybe there's special ways we can get around that problem. So if the knights chest pool, tree pool, trees. That's what I've been trying to teach my son. And he goes, these. Yeah, we go through the woods, and it's on like my front. I go, tree, and it's like, gee. Just get in there. I don't think it's too big of a concern because the outer loop contains the logic determining what things you're going to get back. So you might want to see that. Right. You could pass iter to deferred delete. Sorry, delete deferred, so that you would know where this ref comes. Yeah. I guess. Yes, that's another way as well, is like the ref is actually an offset from a particular typed pool, right? That's another way around it. Yeah, so maybe there's a way. But yeah. These pools are probably gonna have other things, other arrays of things, maybe like metadata I don't know yet. Like is allocated a counter bit or something? I don't know. Or maybe that goes elsewhere. Yeah, this is all definitely very loose still. So I guess problem number one is, what is an entity ref? Like, we know it's a direct reference to a particular pool entity. So it will point to either a chest entity, a tree entity, or a knight entity, and specifically to the slot. But if you keep it across frames, it's probably invalid because we've moved the slots around, right? We've defragged the system. So when you have one of these in the high bits, it could have the archetype. That is a thing it could have. And so when you say coordinate get, which is a property, it looks in the high bits, gets the archetype, and then so this is where you could have a 2D array, right? We index a 2D array, and then you could get an offset from the entity sys, and that will allow you to get one of these pointers, right? So maybe there could be like a 2D lookup table, because I'm not going to have many archetypes and many properties. So I could have some sort of offset table, and maybe this could be calculated at compile time, at Codegen time. So we could probably say, because we're looking at the entity ref coordinate field. No, it can be done at compile time. Yeah, because it's not typed, is it? Yes, the ones that could be done at compile time, if you know the archetype and know the property, those could be done at compile time. But otherwise, you've got to use the lookup table. So this would just be a lookup table to say, can you get me the property? The property is property arrays offsets, and it'll just be an array where you index it via, like, it's a 2D array of archetype, index with the archetype and the index with the property. Bearing in mind it will probably have holes, right? Yeah, definitely have holes in it if you put the wrong property in there, say. So with this approach, it would then mean when you do a get, it would have to do a lookup in this table. But when you're iterating, hopefully this table, so this could probably be a U16, because you won't have 64K's worth of pointers here, right? So that could then, well, yeah, so this table would definitely have to, yeah, so you want to have 64K's worth of pointers. So you could index into that table and retrieve the offset, and then you can grab the pointer to the pool of healths, and then offset from the pool of healths with the entity ref, right? So in the entity ref, you saw the archetype. You'll have the property ID in the function. That'll get the offset. You get the health, or the coordinate rather. And then in the entity ref, you also have an index for which entity it is, and you'll be able to put out the coordinate. That's one way of doing it, but it involves a lookup table, which, it'll be per iteration per property. You'll be calling that lookup table, and there will be padding between things, but it might all fit in cache. What programming language does my son prefer? Well, he's insane as Dad does at the moment. Everything is Dada. So he's just got a single way he identifies the world at the moment. Every object is Dada. And yeah. So it's whatever language allows you to express Dada. And just Dada. Milk script. Yeah. Bow. The entity ref probably needs 2 offsets if the main API pointer gives me, because a lot of things will need to know what pool the entity is in. Yep. Yes. So yeah, probably an archetype in there basically. If you allocate the pools as a header for the arrays, and it's all in one block, then the entity ref could include a base pointer to the pool and an offset to the entity. Yeah, interesting. Yeah, base pointer to the pool. Yeah. Yeah, see that's the thing, right? With the entity ref, if we made it a U64, Yeah, you could probably store the offset into the pool, without having to do a lookup table. But you'll still need to do this lookup table if you want to know the property. Yeah. If you just use an entity ref on a typeless, this typeless entity ref just to get a coordinate back, there's no good way really just to get the property array for any archetype. You would still need one of these tables. You could probably make a smaller table if you was to wham this in the archetype specifically, but then you need a way, so you'd have like the archetype properties count, right? But then you need a way to translate a property to the archetype property by looking up in another array somewhere probably, but it would compress the tables down. So more could probably fit in cache, but it would require more lookups, if you will. Yeah. I think this approach could work for the typeless ones, and the typed ones would... Yeah. You probably have typed references as well, maybe. So like tree ref, night ref, and those wouldn't need any of that stuff. Yeah, or you could do a consecutive list. That's another way of doing it. You don't want to allocate pools as a header because you need to iterate over them and determine which pool you need to query, right? You just make big pools and store the pools in an intrusive list, but I don't know what the game idea is. Right, okay, yeah, lots of pools, right? Yeah. Yeah, see, that's the thing, is like I wanted to... See, the archetype approach solves the problem where you have a bunch of empty slots because not all entities have the same properties. But that being said, you want to make sure to know when to split down into different archetypes, because if you just split into very fine grain archetypes, you have the same problem again, but you have padding on the end of, you have barely any entities in a pool. So you basically have, you're not picking up a cache line filled with entities, you're picking up a cache line filled with padding at the end. So yeah. But that is the other approach, right? Instead, the reference is an offset into a big, like at the end of the day, I'm probably not going to have more than 4 gigs. So maybe we do one big old allocation that stores. So all of these arrays are, so you have an array of coordinates, and that is all of the coordinates you'll possibly ever want for the nights. Then the health sits directly after that in memory, and meshes sit directly after that, and so on, to the point where the next pool also does the same thing. Wait a minute. That won't work, will it? Because you've got... Yeah, that wouldn't work because... Yeah. Right, back to the drawing board on that one. That's not a good idea. Or you could store a base pointer to the entity, base pointer, then the entity index. And you have an array base. One is in the pool already. And do nothing, the pool is going to overflow. Yeah, that's what we'll do. I want to do fixed size pools. So the way I'm thinking about doing it is each region gets... So we'll have one pool per archetype, but we'll have fixed size allocations per region. So where's the thing? So here's the knights, and here's its coordinate array. Obviously, there will be many other properties with the same size and everything. Each region, this will be region 000, 001, 010. Each region will fix allocate, say, 64 knights, because that's the most we'll have per region. And we just won't allow in the game code for knights to move between regions if there's too many in one region, right? It would always check when it tries to move to the next region, can I move there? And part of that is there enough room in the region for another knight? If there isn't, we disallow it to even go in there. So it will never overflow. So this is the strategy I want to go with. But yeah. I should probably come up with better examples than knights and things, because knights is very specific. We're not going to have a knight archetype. Probably start off as like a dynamic object and static object maybe, and we'll go from there. So basically your pools are... Here's big blocks with entity data are linked to each other for iteration, and a reference for a pointer to the pool, right? Yeah, 64 is too small. Yeah, but yeah, there'll be some amount of entities per region, which is a good amount. Because you'll be saving iterating over a ton of entities, but yeah, you got to find a good number. It might work out that we only have like a few archetypes, and they're kind of not very obvious when you just look at the game. On the outside, they might just be very, depending on how the systems actually work under the hood, right? It might be very general. Hey there, Milky. Thank you so much for the raid, sir. Appreciate it. How are you doing? Welcome, raiders. So we're currently working on an entity system, or a code generator for an entity system. But I'll give you a bit of a brief tour of what we've done so far. How did the stream go? If your regions are too small, then you probably have issues with 70k entities because they'll just fragment between pools. Yeah. I'm not sure. There'll be a defrag frag process though. But yeah, we've got like ray traced ellipsoids with like a BVH on the GPU. So we're taking a pause from graphics. It's got PBR and things with like 2 lights. So we're currently just going back to the game technology side of things, getting that up to scratch, because right now we've just done graphics. So I'm just taking a little break from that and making it so that we can ultimately build models in the game made out of ellipsoids. So yeah, any questions, feel free to ask away. We're currently trying to code gen some kind of DoD entity system. We've just got an API together. Well, we just got an iterator API, just sketch one out, and trying to figure out how the hell we're going to actually implement it behind the scenes. Domain entities mean the memory pools will be fragmented because there'll be lots of them rather than a few big blocks to iterate through. Yeah, see, that's where you need to keep the... Right. But the point is say if you only have this many... So the night pool will still be one big pool for the whole world, right? And they will be fixed allocated. But the beauty is the iterator only really wants to search stuff within a region or 2 regions or maybe 4 regions at most for a particular operation for a single entity. So at worst, you're going to be visiting 4 different kind of fragmented pools. Like 4 different pools which have a bit of padding in between. I hope. But yeah, it should be less than that, hopefully. But by having them in these different regions, you'll be iterating over less entities overall, right? Because there'll be a whole world of things. So there's some line between how big these regions go, how many archetypes you're going to have, because you ideally want to have the regions filled with enough entities such that you pick up at least a few cache lines, right? I'm not sure what that number is, but yeah, some number of cache lines before you change to the next pool. And you want to avoid having many pools, because if you have too many pools, you'd have to go through many different... You have to stop what you're doing, go to another pool and start loading that memory. So yeah. Oh, that pasted like 3 times. Like, you want to process 70k per frame, you don't want to do that in distinct chunks of about 100 elements. I see, you didn't realize that was a plan. So it's like a global night pool. Those arrays are subdivided into regions. Yeah. Yes. Because otherwise you're iterating over 70,000 entities and you're basically going to be like, oh, this one's way too far away. So this will save time. It's just not going to be like the most... Yeah. Yeah. Do you want to guarantee the validity of entity ref across frames? Because if you don't, you could avoid fragmentation at deletion by swapping. Yeah. Yes, yeah, so that's going to be the plan, Glorious. I'm going to add... There'll be an entity ID. For now, I'll just type def it, but it'll be strongly typed. There'll be an entity ID which can get turned, which is going to be the long... This one is persistent across frames, and then so we can defrag all the entities within the pools, so they would always be contiguous within the regions. So that'd be pretty nice. Okay, nothing to do with programming languages. That's good. Python. Yeah, so I think, so is there another way other than this silly old property offsets array where you do a 2D lookup, or maybe it'll be a 1D lookup, right, really? Well, yeah, sorry, it'll be a 2D lookup, right? It's been multiplied by, anyway. Yeah, it's a 2D lookup, but it's one pointer you're going through. Then you get an offset, which will get you the pointer of healths, say. So you're passing the archetype and then the health. So the archetype would be tree and then health. And that'll get the offset from here, which gets you a pointer to this pointer. You can then deref it, get that pointer, and then offset with the index of the entity to get the health, right? But you'll be doing that every iteration for every property, and that's kind of crap. I wonder if there's another way to do it. I think the downside of subdividing into regions might be the density for the global processing would be efficient if you make sure your regions are close to 4 at all time. Otherwise, there's lots of holes. Yeah. Yeah. I think that problem is unavoidable, though, because things are going to be happening randomly in a simulated world. But yeah, you want to make sure that there is at least a few cache lines worth such that you're always picking up at least, the more full things you pick up, the less the last unfull one is a problem. But yeah, I don't think we're going to be, say, let's iterate over all the entities in the world. That's never going to be an operation. The operation is always going to be locally around some space, give me the entities. So that is always, yeah. We will have to move entities between regions as well and things. So could there be another way that we structure the data such that so if you want to iterate over all the healths, could you maybe put all the healths next to each other physically in memory? Is that a good idea? I'm not sure if it will be because so maybe say if the knight and the chest and the tree all have health properties, say all the healths were next to each other in memory, say per region, instead. Yeah, but then you wouldn't be able to index. Yeah, the index will be different for each property then. That wouldn't make any sense. Right, that's a bad idea. That doesn't work. Any other ideas? Right. What I'm envisioning from what you said is that you know the maximum number of entities you'll ever allocate all the properties contiguously. Then divide them by the fixed size chunks and put pointers in those arrays in the pool. Right. You allocate all the properties contiguously and divide by the fixed size. Yeah. Yeah, exactly. Yeah, exactly. That's right. So there'll only be one allocation per property, but maybe I could just do one allocation overall and then just offset it and build all the pointers up. I don't quite get one thing. If the pools are fixed sized, then how do you generate property offsets for the get and only store the relative pointer to... Ooh. If the pools are fixed size, then how do you generate the get function and store only a relative pointer to the pool start? The get access functions. So the way I envision this working, I guess I should write the code out, is that, all right, let's get this one here. So I imagine you get the archetype, maybe you call like ent archetype, yep. So you would then just say ent ref archetype. This would be like stored in the high bits somewhere. Then I imagine you do something like entity system, property arrays offset. And you'll be like arc type times by ent properties count plus ent prop. Wait. Oh yeah, the prop would be ent prop coordinate. Yep. So that would then index and get you an offset into so you'd then do, you know that the pointer type is going to be this type. So you get pointer to it. And then you say entity system plus, so that'll be an address of that, plus the offset. And that way you get your pointer to the start of the properties pointer, and then you can deref it. So this will be the coordinates for archetype, right? And then you can, so imagine if we're passing an entity reference, which is a tree, it would have an offset from this base pointer, or yeah, from a base pointer which points to this, which gives you an offset into this thing and gets you to that one, right? And then you can get this pointer by dereferencing that, and now you have this pointer here. And then you'd return chords for archetype, index, and ref. You probably put that in a local. Entity and index. There's an index into the pool. Something like that, right? And I want to try and avoid doing this all the time. That's my aim. Does that answer the question, Glorious, sir? Or is there something else I was misunderstanding? So they would be able to, yep, right. You need to store the indices into the pools rather than the indirect. You need to store the indices into the pools rather than direct references to entities. Right. Needed anyway, as the entity is stripped across pools versus arrays. Yeah. Yeah, exactly. It needs to be, yeah. I can't have a reference, unfortunately. All right, let's have a gander. Oh, you imagine doing it, storing it in line. Excuse that as boy outside randomly doing that. That kind of. Yeah, I think that double pointer, maybe. The pool could store an offset table that can't be generated. Huh. Then you get the pointer to the offset table and an index. So you get the pool base. Right, so it'll be in the iterator. Interesting. Yeah, so maybe, okay. Then, yeah, because then this would the iterator would cache it, wouldn't it? Hmm. Yeah, so maybe we have the functions that I've made. So you save a lookup, but I don't know. Yeah, but when would I want to do that? I don't know if I would. Right? Yeah, this is probably the way we want to do it. Then is you store the data, the necessary data within the iterator, and then the issue is this. Because this would be different for every archetype, right? So you'd have to know, you'd have to have within the iterator the offsets for each of those properties somewhere to get the right pointer. Yeah, so maybe you'd have a lookup table on the pool to get the offset. So maybe this iterator strut can have a bunch of. Right, let's try another version. So we go back to making it use the iterator. We could then say it could, you could say iterator, and maybe this is like you have the offsets in there, prop offsets. You would then say ent prop coordinate. And this would be the offset for this archetype, offset for archetype. Then you would then add the offset to the pool. So archetype, pool, it's just a pointer to that, isn't it? You would then add that offset and then do the casting. And then you've got yourselves the coordinates. Coordinates for archetype. So that, I don't know, is that any better? You still need a lookup. I wonder what there's ways to get rid of the lookup though. Yeah. Yep. There's always a problem somewhere with an ECS. Awesome. Pastebin would be helpful. Yeah, it would be more cached, possibly. Well, would it be more cached? Because this is still cached, right? You're still going to be hitting the same thing. I think it's still the same problem. Well, it's still the same thing. Like this will still be cached. And these could be so small they could be U16s. You know, you can fit 32 of those in a cache line. So we should be able to fit it all in cache quite easy. So it should be alright, I reckon. Right. So you have the iterator. The entity index within the pool, right? The current one. Yep. Then the current pool base with a lookup table. Yes. Yeah, this is basically what we've written. And this basically ends up with the same. It's the same kind of. Yeah, it's the same kind of problem. Yeah, I think these are. Yes, so that's the same as this one. And basically this is also the same, but instead that property offsets array is just global. But yeah, it would be kind of better if we could not do that, but I don't think it's possible. So I think we might stick with this for now. And this way you could make it work with entity ref as well. So it could just work. In the pool rather than globally, but I don't know what makes more sense. Yeah. Yes, you have a different. Yeah, so rather than having it as a 2D array, it's a 1D array in each pool. Yeah. Difficult to judge. Yeah, all the other approaches use search. Could you do some SIMD intrinsics? But I think it would be better, right? You still have to read something to know which one it is. You still have to say. Yeah, you might be able to pack it more by if all of the properties fit in a byte. Do some SIMD intrinsics to find. I don't know, but I think this is just okay. Does it rely on compiler optimization somewhat? This is why I think bigger pools make sense, because the bookkeeping is less important. Oh, you mean not having archetypes, Jack? Is that what you mean? The global variant relies on optimization somewhat. What, because the why does it rely on optimization? There'll be the memory layout would be the same. Is it the multiply then add and then adding that result to the base that base pointer? Is that what you're saying? Something like that? But yeah, I don't know if there's another way we could store. So the other one would be you can only iterate up to a certain number of maybe you can store the pointers in an iterator and then simply so the other API is that we don't have these specific getters, but instead what you do, and this might have to be, yeah, this is probably the only way we could get a better approach, is that instead this is, you know, property 0 and this is property 1. And maybe what you say is entity iterator property 0 coordinate or whatever. But there'll be a lot of, and you have an array of pointers in the entity. So maybe you make a, figure this one out. Iterator coordinate get, you pass in the iterator, right? So this would then return, so with this one, in the iterator, you have all your pointers in there for all the properties, prop arrays. And you simply just pass in, you have a thing here, which would be the property index, right? And then you'd say prop index. This will get you a pointer to the property. And then, so you cast that coords in archetype. And you cast that like so, right? Then it is as simple as like this. And then in debug builds, right? So debug builds, you go if debug. You go, well, in the iterator, make sure that prop index has, so prop types, you say make sure that prop index equal ent prop coordinate, right? So I guess that'll just be some kind of assert where you're like, well, hey, this, so that is probably the way we should do it, because then it becomes a case of looking at yes, one offset and dereference, but it is a bit less readable in the code, but you're barely doing it anyway, right? You have to hard code a number in, but I think that's okay. I'm wrong, the compiler would emit a constant offset into the even and debug thing, right? Although in the approach with the lookup table acts as a property, it's right. Oh. Yeah, you could store them in order. That's interesting. Is that what you're saying, Jack? Yeah, maybe that's, you could use like a count leading zeros. No, wait, you can. So if you have like a bit set and you just have each property set, yeah, you could find which bit is Right. Oh. Yeah, this could probably be made smaller. This could actually be made even more compact because these will all be multiples of 8s. So you could probably use a bit for each one of these. Yeah. We should do that still. But you didn't mean that. Well, you just gave me a good idea regardless. Although in that approach, the take acts as property bit set. I mean, you need a bit set in my approach because the lookup table in the pool can act as having negative in. Yep. Right. Yeah. Oh, yeah, you would. Yeah. You'd always need. That's a good point. With these guys, you'd always need a way to make sure that the entity actually has that property. So you need to assert it in there as well. That's another assertion you need. Something like entity has property. I think the separator with bit sets is better because you can easily SIMD it. And it's more packed. Because you easily SIMD it, it's more packed. Well, SIMD this. But see, I think this could be boiled down to something like if you have a bit set, you can know oh no, you're not doing it once per pool. You're not doing this once per pool. You're doing this every single time you iterate over an entity. But I guess you're doing it once per group of entities if you're SIMD in it. This is why I wanted to make it less code. So this should be better. This approach. Or it's a little bit more of a fiddly API. I think separate array with bits is better because you can use SIMD it. No, checking the properties existence in the pool. Oh, right, I see. Yeah, so what you're saying is storing it all in... Yeah. Okay, so... Yeah, so you probably have some form of bit set. Maybe it should be U64. So you say like pool properties bit set. I don't know, you probably have... Yeah, because you can SIMD it maybe. In the... Xavier is in a report, you only need to check the properties on the pool once. Then an extra check to look up the property value is only needed for debugging. Yeah, but yeah, if you go with this approach, that is not true. But yeah, if you go with this one, this new one we've just come up with, then yes, that is true. Because the problem is this will need that entity property coordinate every time. It'll be using this, which is not like this is just an enum representing a property, and not every archetype has that property. So we need to always translate that into an offset. So this approach stores the offsets. Well, it doesn't really store the offsets, it just stores the base point. It just stores a pointer to the it just stores the actual whole pointer inside the iterator. But you have to call it via prop index. So when we do this iteration API, this would be 0. This wouldn't be anything because we're saying make sure that does not exist. And this one is will be 1. So when we get them, iter coordinate get, you'd have to put a 0 in there because you're saying that's property 0 in the iterator. So we'll just use that pointer. Then will we want to use the entity ref here? B, you need a way to set and get each of these. And then you could probably defer delete it as well. Well, you get your entity ref back. So that'd be entity iter. Yeah, and then if you want the weapon, it'd be a similar thing, enter iter, but this would be 1 instead, right? And we've got the assertion in there, which could be compiled out, which would be a guard to say that property index has to be equal to this property type of coordinate, right? And that should do it. No, because the whole point is that you want to keep this small and in, well, I guess it would be in cache, but then you'd have many different, like this will keep it all in one cache line, but it'll make the code less readable. But it won't be that bad, I think. That's the issue with it. You could actually just, you could do it this way. You could do it that way. Where you just store the offset. We just store a bunch of pointers in there. Or you could just store the bit set in there. Yeah, and a base pointer. Yeah, maybe you wouldn't need this. Maybe, okay, there's a third way. Maybe you're on something, Jack. Maybe, if you ditch that, there will still be that idea you guys had earlier with that sort of base pointer. Right, base pull pointer. Wait, that's just in the iterator. But you get the offset for it with some sort of like I feel like API kind of isn't what you want for the sake of iteration. Like in the case where you want to batch SIMD, you probably want to iterate a very specific property contiguously without doing this lookup stuff. Don't get me wrong, this API is useful for other things, but it's for a lot of extra steps. Yeah. So to batch SIMD process stuff, as you want to iterate very specific property without any lookup stuff. Yeah. Yeah, I wonder how would you do that? That's the other thing we'll solve. But then you ensure that prop array 0 is the right offset in every pool, which is not right. You would be able to batch SIMD it though, wouldn't you? Because in SIMD land, right, you'll just get, they'll be contiguous in memory. So you do this lookup thing in non-SIMD, you get the base pointer for that, then load 4 of them, right? So that's still, you're doing the lookup once. See, unless with the current API, I was book for every yeah, maybe you could get bookkeeping for every register rather than the whole pool. And then move to the next one. Yeah, but the problem is you'd have to repeat. That is okay, but the issue is you'd have to repeat the same for loop again, and I want to try and avoid that. So that's why I'm trying to make it such that you can iterate over the properties, right? But I wonder. Yeah. I can iterate the whole pools without each property boards. Yeah, okay, so maybe that's another way, right? Is you have a way in the iterator to say, iterate me to the next pool, and then iterate through all the entities in that pool, right? And then you know okay, maybe that's another way we could do it. So maybe part of the API is you go iter. So this iterates over properties, and maybe, right. So you would then store yeah. It's still a similar approach though, right? Yeah, I know, but then like the problem is if you don't do it in a typeless way, you then have to do it in a typed way. And say if you have 4 different archetypes, that's 4 different typed loops that basically do the same thing, which is different. Yeah, so you have to duplicate the code, basically. Yeah, but then you still are back to the same problem, right? But then you're back to the same problem, is you got to get the offsets to the properties because you don't know the property. Like we're just doing like yeah, you're back to the same problem again. Because if you iterate over all the pools separately, you'll still just bag in the data. You'll cache in the data for when you do the next get. Because how are you going to know the pointers to the property arrays unless we store those in local variables, basically? Maybe that's what we do. we store them in local variables. So you go iterate next pool, you get all your pointers, and then you go over every entity. Yeah, maybe that's it. You just do it all raw. Maybe that could be it. So maybe you say, yeah, you do like an entity iter. Generate an iteration loop. No. Yeah, I wanted to avoid doing too much code gen stuff. So I think I got another approach inspired by what Jack has been saying. But I don't know what he's been saying all along. It's difficult to tell sometimes, but it's good food for thought. So I think what Jack is saying, or might be leading to, is maybe instead we can do something like this instead. Yeah, awesome, Jack. Thank you. That'd be cool. So maybe we have this sort of like entity iterator, another one, but this time, maybe it's a similar sort of thing, I reckon. Oh. Right, something like this. We instead you do like a entity archetype. So you'll get back an archetype. And that could be a null archetype as well, I reckon. While archetype. So the first one's going to be invalid. Ent iter archetype. So you go over all the archetypes, and you have to do that first. And if you don't, it will error. Then you go over all of these guys. But you'll get the same problem again unless you pull out the property arrays manually. So what you do is for every archetype pool, you pull out that coordinate array here. And you say entity. So you've got an archetype. You want to be able to get ent coords get, and you pull out based on archetype, this archetype, get the coordinates array, pulls out. And if it doesn't have it, it's going to error. But then you won't get the safety, I think. Well, you might be able to get some safety. We'll see. But you pull out the pointers manually, store them locally. And the weapon IDs say this is optional. These may or may not exist. So, yeah, that's the thing, is if they may or may not exist, that could return a null pointer. And that's fine. So these can return null pointers. Yeah, give you a count as well. Yes. Yeah, exactly. That's what you want. And then maybe you do a for loop over all of them. Because then this would work with the SIMD approach hopefully better. So yeah, maybe rather than returning an archetype, it actually returns like a... the archetype will be in there, but it'll be in the high bits. So you'll get back like some ent iter pool ref pool range, something like that. Get back like a pool range. We can change the namings as we go. Pool range, and the pool range, if it's 0, then it's, it's null. So then you would basically extract out an ent iter pool range archetype. And then the other one would be the number of entities. But you'd also need an offset. Would you need an offset? Oh yeah, no, you're right. That could be a U64. So you could probably get a start index and a count. So you get a start index. So we could probably keep this code around as well, just to copy and paste. And then whenever we want to do any iteration, it can be quite simple to just get set up with, right? So you have a pull range, you have a start index, and then you'll also have a count, which will use less bits. Like that. So then you pull out your property arrays, and then you could just do a for loop. And then this is where I guess you could do some special SIMD stuff as well, I imagine. So your next will be start index, and then you'd be like while index is less than start plus count. And then this is, and then we wouldn't need an entity ref, but you could always make an entity ref. Well, at the end of the day, these two fields make up an entity ref. It's an archetype with a start index in there. So you're just incrementing the reference count times, right? Because that would be in the high bits, this would be in the low bits. So that's a way of making it more... I don't know. That's a way we could do it. Right, so with this approach, you would then not get the safety when you index into these things. Especially if that's optional and you've gone and not wrapped that in a... Well, no, you would get a null pointer back and then you do an index and then it... Well, no, it'd be optional, wouldn't it? Yeah, sometimes you get a null pointer back, other times you won't, and you could get a dead entity. So sometimes you'll need to know... No, not dead entity. Yeah, you get dead entity. Or an entity that has the weapon that's optional and... Wait. No, sorry, I'm being silly. You'll never get a null pointer back. With optional, it could optionally exist, so the slot could just not have a weapon. And if it doesn't have a weapon, you would index into that and be a problem. So we don't have special getters, so that's also less code to generate. But yeah, it's a little bit more unsafe. But this is C programming. We could add getters, but what's the point, eh? As a wise saying goes, to succeed in game industry, you need to write some loops. Damn straight. Yeah, having it as this loop way does make a lot of sense. It's just what about the swizzling though? I guess you would. Yeah, I guess you. Different compilation targets. I guess, isn't it? Probably it. You avoided all the casting. No. Yeah, avoid pointer all the way. Alright, see how this goes. Yes, you got that in there, neat. Property header. Sorry, pull header. Words. So for every property, so there will be holes in here, right? And it points to the next one. Okay. So yeah, there will be a wastage of a pointer in there though. Okay, night pool header, yep. Right. Right. You might want to iterate differently, just less code to do that way. Right, okay. So health get with the iterator is pool plus index into that, right? Yeah. Then that gets you the right, lookup table. Yeah, but this is getting you into your right. I see. So maybe these will have to be U32s. But I see what you're saying. So you'd allocate them all. Yes, the pool would. So all of the arrays. So what you're saying is all the arrays would sit one after the other, and you're providing an offset from that base point. Oh, all the pools. Okay, I got it. Right, and then the entity index. Okay. Oh, the first edition. Okay. Yeah, then I guess that's kind of similar to. Yeah, I think I got what you're saying. But then the iterator was saying the first pools go over all the pools like that. And then, right, so you could do like a. Right. Yeah, then that would have to be a pool equal next pool, but I get it. Yep. If it doesn't exist, right, and then iterate over all of the. Okay. Right, so rather than having a special function that you're doing it manually in code, I see. Having it compiled versus reading it in XAML or whatever. Well, the fact it's compiled means I can use compiled things like enums. And we're going to code generate functions. So the functions are going to be specialized, more optimized functions. Did you jump across big address spaces? If you're offsetting, right. So I think this approach is still very similar to this approach, but you're doing it. Yeah, they're still similar to that. Yeah, this is basically the same. But your contribution is the link list of pool headers, and you're kind of the link list of pools as the API versus a sort of like specifying. Yeah, so what you're saying is instead, don't do this where you store it all in the iterator. Instead, just have a way to iterate over all the pools. Anyway. And then check if their properties exist manually in code. And then, yeah. Yeah, but the local teacher pool, yeah. Yep. Very similar though. 10,000 lines, pretty cool, but yeah, the thing is though, yeah, that's the dangerous thing about Codegen is the fact that you just make so many lines of code that it just makes your compile times bad. And yes, that's what we've got to be very careful of that. You know, at a previous job of mine, we code generated like 5 classes, which was 5 files per database table, and we had hundreds of tables, right? So we have hundreds times 500, sorry, times 5, right? Which is thousands of classes just for database tables. It was kind of nuts. So yeah, you got to be careful. Yeah, but yeah, U16 should probably be right. Yep. But I think we can avoid that entirely if we did this arrays approach. But maybe your idea with just say iterate over all the archetypes is just the way. So maybe no, because if you iterate over all the archetypes, you've then got to say yeah, because this function here is going to go ahead and go over all the archetype bit sets for all the properties and be like, does this ruling, does this archetype have these properties and not these properties, or optionally these properties? And then make a little array internally about all the archetypes it needs to iterate over, and then it will step over those and give you the ranges. Yeah, I think this should be more efficient as well when you go to step to the next archetype. Just have them in an array, I think. But if it's just making those in an array, what's the point of the iterator anymore? Do we just want to get a list of archetypes, pool ranges, and you just go over all the pool ranges, you know, and then it's just a bunch of for loops? But then that is kind of a bit of a nicer API, isn't it? Yeah, it just hides them, doesn't it? I think I like the hiding approach in this case. It just makes it easier to, because writing a for loop is a bit, you know, they're making an array, it's just stuff we don't need to do. But the arrays is what we want for the entities. So we can do the SIMD thing as well. Because you have to do the lookup earlier, you don't. You also have the flexibility of just iterating over the property arrays. Because you have the lookup earlier, if you do the lookup information late, then you have to do every entity. Yeah, exactly. Yeah, so I think this is a good approach. I think this is basically, it's very scruffy right now. I've probably just mixed a whole bunch of code, but I think this is what we're looking for. And the SIMD thing, like, I guess we'll have a way to swizzle those XYZs, and we'll just add ways of doing a so you would fetch the coordinates, and that would just be in an in an M128 thing, right? And it will return that instead if SIMD mode is enabled, right, in the code generator. Yeah, I think that's ideal. And then we'll just do the manual SIMD thingy there. Right. I think we've come to that conclusion. That was a lot of... But yeah, this is why you need to write out the code and actually... and then try and see how you can implement it. Because if you didn't do any of those 2 steps, like, you're missing something and your API is going to be completely flawed. I've done it so many times where I've like thought about the implementation and the API design, and then I'll go and write the usage code and I'm like, this is terrible. try and use it. And then yeah, if you don't implement it as well, you get tons of problems. So this is good. So I guess let's consolidate everything. So let's delete this. So what are we keeping? So we've got this thing called an entity iterator. I guess I can shorten that to iter. I want I would like I think this is still pretty cool. We definitely want this pool iterator range. So I guess that would probably be some typed, well, it could just be some integer, I'm not gonna lie. I don't really care if that's but yeah, there'll be some kind of thing we've got to define. This will probably be in the core. This won't be code generated this type because it's probably just, yeah, we'll probably have some max number of archetypes or something. I don't know, we'll see. So we get the archetype out, this will be the pool range. You also want to be able to get the start index out. Now, do you want to get a reference? Because a reference is like yeah, we could probably get it as an entity reference as well, but individually you can get it as an archetype and a start index. Well, maybe you can make an entity reference from a start, an index, and a archetype. Yeah. Cool. So there's ways of shifting stuff out there. And there'll obviously be a way to initialize one of these. It would just be like archetype, start index, and then account, right? So we just pack them all in. So figure out that in a bit. That's cool. You could pack offsets array by translating indices from process from global. Ooh. By wait. I missed what Jack was saying. Yeah, I don't know if you want to store / iterate over pools, but iterate per, but probably per region. How you do it in that bit doesn't matter. Yep. It also doesn't care about using SIMD or not. The pool iteration is done in the same regardless. Yep. You could pack offset array by translating indices from pool properties bit set. Yes. From globally defined index or locally to locally, yes. And you know the health is 3. You find the amount of bits set before, yes. Yeah, that's what when Jack gave me that his idea, that's what I thought he meant. That's a good technique, isn't it? We can squish the bits. We can squish it down from a big lookup table, potentially big lookup table, down into just a bit set. Totally fried at this point. Yeah, my brain started off fried, but I managed to unfry it somehow. But yeah, so we should be able to pack it down by knowing, like, if we have property health, and that's like 3 or whatever, we should be able to count all the bits. Yeah, we should be able to AND all the bits after it. Is that right? And do a count number of bits that are set, like a population count, I think it's called. And then do the difference between the number of bits that could be set and that. and then that's the number of pointers you offset by or something. It's something like that. I think it should be possible, and that should be more efficient. Or just use less memory. I don't know. You could definitely compact that. I just don't think it'd be worth it. The cost for the lookup table online. Yeah, maybe so. Yeah. Yeah, fart count. Good old fart count. Yeah, exactly. I don't think I'm going to have that many properties, so I think the tables will be quite small anyway. But it's an optimization that could be done. Right, so I think we got it. So let's just finish up sketching what we want. So that's cool now. Let's go down again. So entity iterates an archetype. So maybe, or maybe we say next archetype. This be a function that returns one of these boys. Oh, what am I doing? So it'll be like an int iter next archetype. Or I could say next range. And then you get a pull range out. So you just say like, oh, int iterator. Point to that, please. And voila. Yeah, so next range, I like that. It's good. So BW. Right, so we do all those sort of gets and voila. Then this one is saying like, hey, for a given archetype, get the coordinates pointer for me. So this is kind of like the thing we did before. So this would mean that if the property does not exist for that archetype, it can assert, but it won't catch you indexing the array wrong. But that's okay. And so I'm thinking about my system with my multi-threading. Maybe we could have a way that if you pass in a pull range, it could do it such that it does the bookkeeping thing as well if I'm still doing that. Yeah, I think I'll add that later. But we'll still have these things. So you can just get the arrays for the properties. So entity props. Should I just call it entity coords pointer? I've got to think of a good name, but basically we're going to Codegen. I think it would kind of be similar to what these were. This one probably, so let's put this one here. So I think it'd be like an entity archetype coords pointer, coords array, maybe, and you just get the base, you get the pointer to it. So you're just passing the archetype. So that'd be something like a ent archetype, and then you got the archetype. It knows how to do all of. Yeah, there's some offset system. Maybe we do the thing with the population count we mentioned earlier with the bit set. But it should only be U16s, and we shouldn't have a lot of properties anyway. Then cool idea. As I also said, that I think got lost. You might be able to get away with the U8 lookup table values if you let the pointer arithmetic do its thing with pointers to pointers. Right. Although you might have to make sure that the alignment of everything works. Right, so what you're saying is if we can guarantee that everything that gets code generated in the entity system from the base pointer is, if they're always pointers, then you can treat the U8 as essentially a filled index, and the index into an array of pointers and get your pointer out. Then you can pack it into U8. That could probably work if the total number of, that could only work if the total number of properties are less than 256. But yeah, that could work. Oh, the pool strut. Oh, within the pools. Ah. Yeah. But again, the pool strut might be small enough. Get away with it. Right, yeah, so if we had the array per pool, you could definitely do that. Like, it would never reach more than 256 properties in an archetype. But yeah, that could do it. So that would then mean you pack, but then how you get to that is you still need to somehow, with an archetype enum, can get to the archetype base pointer somehow. So you'd need to have the pointer already, which in your approach did. Yeah, but how do you get to the pool base point, the base pointer? How do you get to the base pointer of the pool with the archetype enum? Is that possible? Oh, the first time, okay. That's cool. Yeah. We'll see. Yeah, that could work. Right, so this would be how you get the arrays. We'll code gen a bunch of these boys and girls, right? Archetype property array, you can get them out. You need to also assert somewhere that this archetype has that property. So if you did it with a bit set approach, so if you called it like archetype so you need a bit set anyway. So archetype props bit set. So you would have some indexing, and let's say we only have 64 properties overall. But we will probably go over that, but let's just limit it to that for now. You would index and get the bit set for all the properties. Like so. Then you could do given yeah, I think I'm going to get rid of the lookup table because it's probably the property bit set is already going to need to exist. Okay, that's cool. Yeah, so I think the this archetype properties bit set is always going to have to exist anyway for assertion logic. So I think will just be, well, okay, in release builds it won't, but yeah, it will just be one table that way. But that is a lookup table being invalid. No, not sure what you mean. Yeah. No, but actually, you would still want it. No, sorry. You need it in release builds as well, because when you call this iterate thing, it needs to go over all the archetypes and find which ones have a coordinate and optionally a weapon. Maybe. There might need to be an optional one as well. Another bit set, we'll see. Oh, that should do it. So, props bit set. We need to work out the mask. So if, say, ent prop coord is like 3 or something, you need to be able to get a mask of the 3 low bits, right? And keep those. Wait, not the 3 low bits, the 2 low bits, because that represents, oh no, the 3 low bits, yeah. Keep those, and then do a population count on the results. So if we've masked it out, we've got something like this. Then do a pop count, you'll get 2. And then wait, we need a more higher example. Let's do like 5. Right. Then let's say it's like that. You get a pop count of 3. Yeah, you just offset 3 pointers then, isn't it? That should be right. Yeah, exactly. I need to mask it away. That's correct. That is correct. So we should be able to say props bit set, mask away, ent prop take 1. That will get you the rest of the bits, or the low. Let's call them low. Oh shit, what did I do? Then, so that gets you the lower bits. Then with the lower bits, you should be able to do like a pop count and get the number of pointers to offset by. Wait, why am I doing this again? Would you have to do this for, So there needs to be an assertion, that is for sure, with this. Ent prop. So there'll be some assertion in there, that's for sure. That gets generated. Make sure it does exist. My only worry is that this will give you an offset into, you still need to get the base pointer if you did it this approach. Oh, it's a number, isn't it? We need to 1 shift left it. Whoopsie. Thank you. This information is all encoded in the pool the entity is in. Right, because the pools are per archetype. Yeah. Yeah, but you don't have the... Right. Yeah, I could just have the base pointer to it, isn't it? Yeah, so in the iterator syntax, oh sorry, yeah, with the iterator API design, we rather than get the so that could probably fit into one U32. Then maybe you have an offset to the archetype. Here. Offsets the archetype pool. Is that what you're saying, Jack? But yeah, then you wouldn't go into the entity system, isn't it? So you're saying like pool offset basically, which is basically archetype pool offset. You need some kind of lookup to get the property base pointer. If you need to get the property array base pointer, then that lookup can tell you if the properties are invalid or not. The current pool can have the archetype, right, rather than... Yeah. Yeah. We could probably give it the pool, and we could probably give it the pool pointer. The issue is, yeah, we'll probably give it the pool pointer, and for debug purposes, store the archetype in there so we can print out stuff. For this offset, so you probably get back a pool offset instead of archetype. But archetype could be useful, but you can always turn an pool offset into an archetype. Maybe you could have both, because this should only take a few bits up. And if it's a U64, you could probably get all information. So I expect people just to copy and paste, or me anyway, just to copy and paste an empty one of these and just change it around. Yeah. Yeah, maybe the archetype could go. I don't know if I really want it in an iterator, to be honest, because the whole point is that it doesn't. Yeah. Yeah, the pool offset is a better idea. That's good. So, yeah, you would then get the pool offset, and at the start of every pool, there's always the lookup table pointer. So you would, I guess you could get the pool header. Maybe we'll do the pool header approach, but not link list it like Jax had in his thing. Maybe we have a way of getting something like this, right? Just so that it's typed and it's not unsafe and less unsafe, right? Yeah, legit. So then this would be U64. We'll probably have like a bit set for props bit set, and maybe we'll store the optional ones in there as well. I don't know where the optionals will go. We'll think about that at some other point. But yeah, this is a good idea. So then instead you're saying pull chords array. And then it's not really an archetype thingy, right? That's a good idea. Ent pull chords array. So you just do one of them. Get the pull pointer, pull pitter. Did I call it bit set? Yeah. So you do like a pull props bit set, no array lookup, just assert that it does exist. Then you could do the magic low bits, then population count it. Wait, I've got like a bit count, isn't it? Bit count. Yeah, bit count. It says cross-platform. It's in my maths library. Bit count on the lower bits, and this will get you the number of the property array prop arrays index. And then with this information, so yeah, say we've got it's 5, we get the low bits by masking out anything that's past the 5th index. Wait a minute. One shift left, because this is an index, right? So that's 5. One shift left 5, take 1. That gives me 5 bits all turned on. Then we've got the lower bits. Yep. Which will give us this sort of like 10101 maybe. Right. So it's saying 5 is on. So it does have a property coordinate for this archetype or this pool. Then we can simply do a count bits, and it'll give us 3 back, and that's our property array index. So we should be able to maybe use the flexible array member. Who likes a bit of C? Flexible array member. Props arrays. Prop arrays, property arrays. Props arrays. Bit of flexible array member. Is that you can sort of contiguously iterate them nicely? Yep. Right. Yep. Yeah, you want the bit count. Yeah. So then it should be as simple as then it should be as simple as getting the pointer out, which would be what I guess we'll put into a local, right, for debugging purposes. This is the coordinates. That would then be pull property arrays, and you do prop array index and return coordinates. Look at that. Much better. That's really cool. So that's made everything. Yeah, so we'll be dereferencing the same piece of memory basically, and then indexing into this, which should all be cached for the however many times we want to do it. That's good. So could this be made more general? Does it have to be a distinct? Yeah, it does for the type, the return type. But that's okay. I'm happy with that. So this is basically typeless, except for here. But that's okay. Cool. I really like that improvement. That's really good. So I could call this archetype pool, right? But yeah, the header is a, you know, but pool is, yeah, let's just call it pool header. Very nice. So there's a way. So inside the, because we're going to be using global variables, we'll be able to get this with just an offset. But yeah, we'll store a pool offset inside the iter range thing. So this will get you the pool. So I think we'll be able to say extracts the pool out. So this will give you a pullback, and you pass in the pool offset here, and this will extract out the pool offset and do the, do the offset, get the base pointer, and return that. That'll be sweet. So then we can iterate over all of the. So we get the coordinates. So that'll be pool coordinates. You pass in the pool pointer, and then this will be weapon IDs get, same thing, get the pool with the pool pointer. Then you do the for loop like so. Just a nice for loop. When you want to get your coordinate now, it's just, okay, maybe you call it chord array because maybe we call it array. Don't put a get on there because we won't be setting it as well. So just call it array, because I don't like just having plurals be the differentiator between variable names. I find it very error prone. Then we say chord array, index with index, and voila. Then if this one exists, right, it's very nice. Return type means it's good. It's as good. That means that as good as you're gonna get it. You can make a generic one that returns void. That wraps it though. Yeah, I could. I don't know if that'll be beneficial though. It might be good in terms of parsing, or reduce the number of things to parse, but it will probably get inlined as well by the compiler. And this way it's manually inlined. I think it would be better if you stored the props bit set in a separate contiguous array, because you would need to be able to SIMD proper archetype search whenever you do the initial iterator call. Yep. When you construct the iterator, and you have separate pool data. Right. Yeah, I think we might do both then. I think we might just duplicate the data. But that's okay because it's done at compile time anyway, or initialization time of the whole system. And have separate. Wait a minute. Yeah. Because you might not get the benefits of storing property bits in the header. Yeah. Yeah, hold the bear. We're hyper micro optimizing here. You only generate the bit shifting. True. So when we do this, we could do it such that the it could be compiled into the function. Maybe because we know like this is all known at compile time per archetype. Could you do it with Nah, yeah, we might just do a separate array for them and then get it initialized at when you boot the system up. I don't because if you did it at compile time, it would just be with if statements, wouldn't it, really? And constants. So it's not really nothing there. All right. Yeah, I don't think we're going to be iterating over many pools, to be honest. I think it'll be quite negligible. Right. So as we continue down, so there's this thing of like an entity ref now that we have lost, but you should be able to make an entity ref, but also you should be able to check if the property exists in a pool. So that's another function. We'll be doing something like this, where you say, hey, ent prop prop, and you'll be returning so prop exists. Does the prop exist? And then you'll be able to do this one, so you won't need that entity ref, but that entity ref one should also exist. But I don't know if I'm really going to use it. But we could yeah, I don't know if I'm really going to use the entity ref thing. I might avoid doing entity refs for now, and if they serve being beneficial when I actually write code, might do entity refs. We'll see. We'll probably just do indirect entity lookups. I don't know if I'm actually going to need them, to be honest. But yeah, so if it has a weapon ID, then we can look in the weapons array. We can then look in the weapon ID array with the index and then pull out the weapon ID, and then we can operate on it, and then we can also store it back in there as well. And we get a mutable reference back, so we can just store back into it if we want a different one, right? So we'll store something else in there. Maybe we have like a weapon gun or something. Yeah. And then we can defer delete some stuff. So when you're talking about defer deleting, maybe each pool has a bit set for every entity that you want to delete. So you just say entity pool, defer delete. Or delete deferred. And this would be the quickest way to do that, is you could then say pool and then the entity index, and maybe you could just delete. But then the issue is you would have to, when you're doing the defragging process, You'd have to iterate it per region anyway. So that would be, you'd have to do it per region, but you'd just do it across all your threads, I guess. And maybe you defrag. You don't defrag all of them every frame. You just do like 128 every frame, and it just, yeah, that should be alright. So entity pool ent delete deferred double R on it, English. So you pass in the entity index, and then this would somehow do that, right? Oh. Yeah, do you want to do it outside the loop? Maybe. Yeah, so you probably are better off storing this outside the loop. That is true. Boolean, so weapon. Wait. Oh, that means done per entity, isn't it? Ah, good point. I dropped my index from it. Yes. So what am I doing? What did I do wrong? Crap. Yeah, you would need it, isn't it? Yeah, you'd need an additional array per, which keeps all your optional bits. Yeah, you would, isn't it? So this is different. Yeah. Yeah. Right. Yep, that was silly of me. There's kind of two different versions, isn't there? You want a bit say on the pool to say whether or not the slot is active. Yeah, yeah, you need to know if they're allocated or not. Hmm. Yeah. Um. Yeah, there will be like the allocated stuff as well, probably, and there probably needs to be some counter bits or something in there too. Right, I'll just take a quick break and get another drink. And we will clean up this issue here. Right, BRB. Let's put the music back on. Welcome back. How's it going? Paya, how's it going, good sir? How you been? Thank you for the sub. Appreciate you, good sir. Yeah, we've just been rather frantically designing an iterator API for the entity system. It's getting there. We're just dealing with some ins and outs of the how to implement some of it. But we're trying to figure out what code we need to generate and write some usage code, make sure it's good, and write some sort of implementation code and see if it will actually work. And yeah, just really with some help of Glorious and Taurus Python. It's going good. It's going to be pretty sweet, I reckon. Yeah, the next problem is the optionals. So the property, the archetype itself can have a property, but it also might not have a property. So exists is kind of different. There's like a has property on the archetype itself, right? If the type has the property, but also if you optionally have a property, if that exists. So the terminology is a bit, we need two distinct terminologies. Yeah. Gotta figure out the naming for that now. But yeah, how's it been? Has input been by how you been up? How you been? What you been doing? Right, let's put that on charge. There we go. Still working on UniBS. Oh no. Did you try and convince the company to try and update the in-house engine a bit? Still selling into the new home? Cool. Yeah. If you is it still a bit weird when you wake up? Have you woken up and just been so tired that you just for a moment think you're in your old place? Good times. Entity property exists. So we have the type itself has the field, right? So this is where I'm thinking maybe we should distinctly call them fields for archetypes and properties more globally, if you will. Then we got a kind of distinct, like a property is like a coordinate is a property, but on the archetype it has a coordinate field property. So that way you could do naming like property exists and then field exists. And then that'd be an entity index, right? On X, I saw you comment on ISPC. SimD wondered if your HC project can be targeted at CM. Yeah, so I could theoretically work more on HCC and make it such that one, I've got to like get pointers in there, and then I could parse the C code and get it to code generate SIMD code, right? By taking the IR and outputting some SIMD code in C and then running that through the compiler or through Clang. But yeah, it requires more work on HCC, and I'd rather just. I think I might actually try out using ISPC, because ISPC supports like all the platforms I probably want to go on anyway. Like it supports ARM, and I could just have a couple of files that just have some SIMD stuff in it. But yeah, it supports Windows, Mac, Linux, and Android, iOS, and PlayStation apparently. So it even does ARM Neon as well. So maybe we just use this, have a couple of ISP PC files in the code base for like the job system, entity stuff, and just do it that way. Or hand code it like a Chad. But I haven't really done too much SIMD stuff, so. I don't know if this is what you'd want. You'd just store the bit set in another property array. Then you just check. Just do the check on the loop. Yeah, this would be a similar thing, right? It'd be a different array though. Oh, right. Okay, you're saying you get the optional. Ah. Right, I'm understanding you. What you're saying is there's a way to just fetch. This would be the optional fields. Optional. That would be a pointer. Good old putter. Be a bit set though. Yeah, but it will have quite a lot of padding. I wonder if there's ways around the padding. Oh, you feel like it's a bad idea? I don't know, like in GPUs it works out quite well, so what's the difference? Like there's like a model that you think about. I haven't used ISPC, and I haven't really done a lot of SIMD code. I've done some, but not massive amounts. So I don't. Maybe there is a problem there, but from my understanding, when you do GPU programming, the mapping works quite nicely. Where it is very much like a SIMD thing. Obviously, the GPU processors are different, but it's a similar type of thing. The common Rust macros and generics would be able to do SOA, AOS reasonably. Oh, okay. Oh, I forgot. With this approach, we won't be able to do the AOS code gen because we get access to the raw arrays. But that's okay. I'm not that fussed about it. Yeah, we wouldn't be able. Yeah, we wouldn't be able to do the AOS thing and switch between it. But yeah, this is way better though. Doing it this way. So, okay, that's cool. I think what we might do then, if you have an optional field, you have your optional bits, right? And wait a minute. I think we'll need an API. So you can get like an optional. We might have to translate it to a different index, and maybe you need the API for it. I'm going back to Jack. So there's a way to get an optional index. You take an ST, pull header, pull prop. So this would probably do. So you want to know like which one of your guys are optional? And that'd be the same logic as we had before. Here. Is the prop? Yeah, similar. So you make sure that it does exist with the prop. Then you do like a low bits. Yeah, it'd be a bit fiddly, a bit more fiddly, but it'd be more optimized that way. Be more packed. Just a little bit more fiddle. But you kind of want to avoid using optionals anyway, kind of. Or be aware that they're aware of them. Yeah, I'm in two places around auto vectorization because you could just change a bit of code and then it just turns it off. But maybe you got to be aware how the optimizer works. But maybe it's fine. This is where wide and scalar code is just different. Yeah. Right, actually maybe you won't need that. Yeah. You just need this to get your optional index and you can pack them in. Right. I feel bad that a stack has slightly been pushed up by Unity. No. Yeah, these things come and go, but I think with the new graphics APIs, it's getting harder and harder for people to make. It's another big reason not to make your own engine. So I think coming back to making own engine tech is going to be a bit of a hard swing back, but it could happen, I reckon. But it'll probably happen on different companies, maybe. Right, so I think we can fetch the optional index of a property. So when we code gen each archetype, you'll be like, oh, this weapon ID is optional for some reason. And that would be given optional index 0. And if you have more, you get more optional indices. And then you have a bit set, which would be, yeah, but how do you, Yeah, because if you SIMD this thing, how could you... You kind of have like a variably amount of bits then at that point, and doing that in SIMD would just not work because you maybe you just store one. Yeah, you can have just 1 byte per integer, 1 byte per entity, and then you have then you would know. Yeah, that could do it. I got it. So I think so. You do your property. Make sure the property does exist. Can be used in this archetype. Then you mask out all the bits. Sorry, yeah, you mask out all the higher bits in the optional props bit set. So which ones are optional? Get the low bits. Do the count, and this would be your optional index, and we'll return optional index, right? Okay, so if you limit each, so I think in the property you'd need that optional props bit set. So you're saying like, so let's just comment these, right? Which so okay, index each bit. Okay. Which properties exist for this pool? You know, it's kind of obvious, I guess. Just spelling out the obvious with that comment. Right, so that will get you your index. So if you have an optional, yeah, you'd need one which gets a U8 back. We'll do a U8 per entity pool optional bits, bit sets, bit set array. So this will just return pool, probably just an optional bit set array. Let's just make one of them. Then, so that'd be one of these here, be void. Or void would be U8, 1 byte per entity. And then if the entities if we don't have any optionals, then it will just be a null pointer and it won't get allocated, right? There's another benefit of doing it that way. So we can then just I guess I don't need a getter. Let's be honest, I don't need a getter. So what I need to do then is for the weapon, I need the weapon optional index. Weapon ID optional index, which would be an entity pool optional index. The pool, I think that's right. Yep. Then when we're in here, we can just do pool optional bits optional props bit set array. Yep. Index with the entity and it with the one shift left of weapon ID. See, this is a bit fiddly. So I think we can have a function which does it because it's kind of nice, right? Then if we need to do it in SIMD, we have a SIMD function. So I think it's possible to do it for both. Yeah, I'm not sure how they do the width independent instructions. I've never looked into it. It sounds interesting. Does an ARM do the same? It's wasted in cases where the entity doesn't have any optional bits. To the other property arrays. It's really simple. There's an instruction which returns the hardware register width that is used for iteration, and loads specify how many lanes are active. Right. But does it just... Yeah, so they have the property for the optional bit set. You know, I've just got it hard coded here. Like, it's just... But why would I need to get it out? Like, this is the same, isn't it? Yeah, why... I'll just be getting a getter for something. Right, but you're saying it will be wasted in the... Right. Yeah, we'll be pushing out other stuff that wouldn't have it. Right, if you just put it in here, right, okay. For the optional bit sets, yeah, that could work. We could reserve the first one for them. But then that means if you have the optional properties bit set, we'll also need to... that could probably be the first pointer. Yeah, every pool will have it, that's true. It'd be a bit of a waste. But it's just every pool. As far as I can tell, the property... So why does it need to be a special case for handling who's in the pool? Yeah. Yeah, not everything is gonna need it, maybe. But... yeah, so this one could actually be... it could be another property thing. But this properties bit set will still exist, which is the remapping. The thing is, though, it's kind of nice having it built in because this could be made a function. And then you say, oh yeah, there's a deletion queue approach maybe as well. That could do it. Yeah, because you won't necessarily be deleting a lot of entities. That's probably a better approach. Yeah, probably submit to the end of the frame. Yeah. So with this approach, it's a bit fiddly. But then we don't need to name it. But it's a bit fiddly. So we could maybe get an optional array out. So you get your optional array. And that would... missing the word pool. So you can get one of those out. So maybe that could be like a special one. And that would save a pointer per pool, which does help out with things, really. But the bit set would still need to be there, I think. Optional props bit set array. Where is it at? Optional props. Yeah, that goes. So we've got this optional props bit set. Yeah, I think I have to stay around. So you mean this code here? So this is indexing via the entity. So we index for the entity first. Oh, you mean the bit set? Yeah, but then it won't be a bit set anymore, will it? You mean in this code here? It does not need to be an array, or it does need to be an array if you have one. You need an entry per entity, yeah. So it's to pack it into a byte. So the idea is, rather than having a whole 64-bit bit set per entity, that's a waste of space. It's 8 bytes per entity. So to pack it down into 1 byte per entity, the idea is to map. For this archetype, you're only allowed up to most 256 optional fills, which you won't, right? So this packs it down into 8 bits. So remaps. Oh wait, where's the weapon ID? So remaps the weapon ID into a linear index of optional properties, basically. So yeah, just remaps something with spaces in it, something with no spaces in it. So Yeah, that'll work. We could probably pack it down into 4 bits and then have 2 bits per one. So if we then we have even less information, because then that's 16 fields. Yeah, repacking. So I think I might pack, you know what I might actually do? I might pack it down even more and then make it a function. Yeah, because 4 bits would be enough, and I want to try and make sure we don't spend too much memory on this stuff, because it could get quite bad. I think we should just get the array. It's weird to ask from the pool when everything else is from the arrays. What do you mean? Yeah, do you mean like don't do the packing step? Or do you mean like I think we should just get the array. Yeah, exactly. I want to add support for the optionals so we don't have to change it to another archetype, basically. Wait a minute. Wait a minute. So yeah, so if I split it into another archetype, I guess this is like the loop logic, isn't it? Where you could Yeah, so the optional thing is like a generalized way of storing bit sets in the entity system itself, right? Could we just get rid of optional and just make it such that if the property is optional, the property stores it inside its own information. And then that way we don't do any of this silliness, right? So say if it's weapon ID, if the weapon ID is optional, it'll just be a null pointer, right? And then it'll just be a null ID. Yeah, maybe that's the way to go. Because this just seems... Yeah, I think that's the way. Yeah. Yeah, this just seems too cumbersome. So we could just say if it's not null. So you'll do a get. Yeah, if not null. And then you can just make it a gun. I don't know. Done. Much better. So we're removing optional. Bad idea. Not doing that anymore. So that's cool. No biggie. So there'll be 1 bit for the not exists in the search algorithm thing. For now, I don't know if there's going to be any more. I think just not exist is going to be it. So we won't have optional bit set in there anymore. Sweet. No optional crap. Goodbye. So we'll encode it directly in the data itself. Much better. Right. This is looking good. So the other one was the deferred delete. So yeah, we're thinking maybe we could do a bit set on every region, but Glorissa pointed out, it's probably a good idea just to make a queue for it, because you're not really going to be deleting a lot of things every frame anyway. So we could just go over all of the deleted stuff and delete it single-threadedly, I think. Yeah. So in that case, you would probably push on a ref. So we might keep entity refs around. So you'll need a way to get a ref from an entity. Yeah, so you'd be like ent ref init, or you just say define ent ref, and that'll be your so you don't really have the archetype at this point. You could get the pool archetype some way. Yeah, so archetype and entity index. So we'll make sure we make that. Yeah, I like having stuff packed down where possible, though. A pointer is quite big. I can do an 8-byte thing though. Yeah, I think that's got to be 8 bytes. Where's my ref gone? All right, ref simd. Yeah, so then we'll just be basically that. We're not going to need a simd ref, are we? Right. Yeah, packing stuff. Pack. So entity ref. We could just store a pool offset. That's another way around it. Yeah. You don't really need the archetype, right? For some logic, maybe you might want to be like, oh, am I this archetype? But the archetype could just be how many bits, right? So pool offset. If we make that a EU64 maybe, you could probably get them all in there. You could probably get them all in there quite nicely. So if we wanted to, we could get an entity ref from... So this one can also store the archetype. Oh, my laptop died. No. Let's get that back. But then how would you get... You need a way to say... You can ask for the archetype for some reason if you want it. And that you do. And then pull the range. But then you can also get the entity ref with an index of your entity. Yeah, so I think we can get it that way when you iterate. Get the chat back up. Chat has been restored. Offset from what? The global entity system. So just offset from here and get you to your pool header. These all need to have pool headers now. But yeah. Right, where was I? Man, this is all changed. Yeah, so perhaps in the code, if you want that entity ref and you want to delete it, ent ref, you would just say ent iter pool ent ref. You pass in the pool range and you pass in your entity index, and now you've got that, you can defer delete it. So that'll be ent ref defer. Did I delete that in the end? Delete deferred, I didn't. Neat. I don't know why it needs to return a billion. Yeah, but then you need to deref the pool. Pack. Pack. NRF. Oh yeah, I have the pool already, that's true. This is true. But what else? Yeah, so you would be looking at it already, but then in the header, where would I stick it in the header? I would need some bits. Maybe 8 bits. So yeah, maybe there would be some, I could probably stick it in there if we put other stuff in the header. Yeah, I'll think about it. It might end up going in there later, we'll see. Yeah, so at least you can get the entity reference here, and then you could add it to some deferred array somewhere. Noise. Yeah. All right. Yeah, that's true. Depends. Right, so that's looking quite decent. What else we got left to do? So let's just, I think this is looking good now. Let's just clean up all of this code we've put up here. So I think I want to have like an iterator. And from my understanding is we want to store, what do we want to store in here? We need to store the array of, essentially the pool ranges in here. And we'll pull them out. So when you instantiate this, you get your pool ranges and you say like, you know, current pool index, you're iterating over, maybe your max iterate over all the archetypes. So this would basically just be archetype count. Ent archetype, maybe we'll call it ent archetype count. So for it, the maximum number of pools is the number of archetypes. So that should be safe. It'll be on the stack. Should be all right. We'll put that last, I reckon. Then, yeah, I think that's it. Yeah, then you have ways of returning. Okay, good. So you have this sort of property things where you say property exists, does not exist. It ors that onto the property. Yeah, then this is codegen, right? Same with the archetype thing, that would be codegen. This is the API for the iterating within an area at a certain radius. The radius will get the regions in an array, and then call this regions function, which passes in the regions to iterate over and the properties, and this will figure out how to fill up this thing here with the right pools. Yeah. With the right pools, we also need to have like a region offset as well. There'll be a start index, isn't it? Oh no, would have filled it up. Yeah, would have filled it up in these ranges already. That'd be cool. There's a nice macro so we can define, it just defines the array of properties and then takes the address. Wait a minute. Then passes in the address of the property array and then the number of elements in there. So it just saves putting it in a separate array. The ref has these individual fields. Probably have a way to bring them out as well. Yeah, it's true. So there'll be a way to get the pool. Do we call it a pool? Yeah, you just get the pool. So you pass in the. He pass in the entity ref, and we can get the pool it belongs to very easily. Since it's just a global variable where it's stored, and we store the offset in there. Get the archetype if you want. You can also get the entity index from within the pool. So I have to have ways of unpacking that. Entity ref is 64 bits. That should be fine. Maybe there's ways to pack it down to even less. Nah, probably not. Cool, so we've got this sort of pool header thing, right? Every one of these guys is going to get a pool header, right? Oh, nearly there. So the entity system is going to have, it's not going to have these things anymore, right? We're just going to have the pools. I think they'll just be there. Entity iterate called get. We don't have this thing anymore. That was just a little idea. We want to have this entity ID thing. This is going to be a one that doesn't expire every frame. So I guess I could say, you know, this one is a more direct entity, a direct entity reference, but will become or can become invalid between frames. Cool. Whereas this entity ID is a more valid because we're going to be using entity IDs for random access patterns, which you can't really optimize for. So it's going to be a little bit more costly, right? So has a level an entity reference that is valid for the whole lifetime of the object of the entity. An entity reference that is valid for the whole lifetime of the entity, but it has a cost. Has an extra cost of indirection to turn over an entity reference, an entref. That's what I called it, right? Yeah. Effectively, an ent ID is always dereferenced into a ent ref. Ta-da! So, iterating APIs. I just called it iter next range, so we've got that here. So this goes like with the ent ref. I don't know if I want to bother with the functions that much because I don't know if I'm actually going to wait. Oh no, I'm going to use them because the ent ref balls. Okay, yeah, we're going to need them. It's fine. So does this property exist on this entity? That's quite easy, right? We've seen that one already. It's this sort of like pull prop exist thing. Ref delete deferred. Yep, we need that one. Then we generate for every property we ever get and set. Yep. So we also should have some functions that allow us to take allow us to get an entity reference. So entref ent from an ent ID. We probably need to go the other way at some point, maybe. Yeah, so maybe, maybe always get the ent ref and then use these functions. I think it'd be such a waste if we provided an easy way of doing it when this is just so easy to do. Right, just do one extra function call. I think that's okay. It'd be more. To be honest, anything in the pool is basically free. Yeah, a few of them. Yep. I think to access all properties and into ref is worthwhile. Yeah, definitely. Yeah, it's probably going to be. Well, no, it's definitely going to be used. Yeah, it's not. Yeah, batch work. Yeah, this is all this sort of like random access stuff, so it's always going to pay a penalty. But maybe there's a point where those random accessed entities get worked on twice in a frame. So maybe I don't know. Yeah. Maybe we can convert the entity ID into entref. The thing is, if this entref was like 32 bits, we could pack them both into 64-bit int. And you could have this type which, well, yeah, I don't know. We'll see later on. Yeah, maybe in some structures we'll have both next to each other and one just gets refreshed every frame. Property exists, defer, delete, get and setters. Getters and setters. I guess if we have some SIMD approach. You'd never want to SIMD with these things, would you? So you'd always just do get a single, set a single. Which means if it's SIMD, it'll be swizzled, and you would unswizzle it, return that, and set it back. That's okay. Right, this is pretty cool. You know, get the next entity range with the iterator. Cool. So the iterator's really kind of got a very simple API, I guess. It's got a way to go to the next one and a way to instantiate it. Like that. Yeah, SimDRF doesn't really need to be needed, does it, I think? Yeah, it's a random access type, that's right. Is there a SIMD one? No, good. Remove that one, it's decent. And prop exists. Yeah, did we just... Yeah, I guess that's an implementation of that already done, thought about. Defer delete, we've not really thought about, but we'll probably do a queue, that's fine. These are all good, and this was our test code. Excellent. Right. So what have we achieved today? Let's take a quick recap. Iterate over properties. Complete. We've done that one. Creating entities has not been done. Iterating over archetypes. Oh wait, not archetype. I meant to say archetype entities. Yeah, we still obviously need to do that, but it will piggyback off this more complicated one that we've done, right? It'd be more simple, so still need to do that. We've got the API has been designed for this already, but I haven't thought about the implementation a bit. Yeah, we should probably try and implement some of these things. Entity create still needs to be done. Typed IDs. I don't think we'll need typed IDs. We can always just go over all the archetype entities. Because if I added typed IDs, what would that do? Oh, so if I added typed IDs, that would make it such that we need special getters, maybe? But you could probably have less. You would, rather than being a 64-bit int, it'll be a 32-bit int. Yeah. Yeah, I don't... Yeah, sorry, I think it's like iterate over archetypes. I don't want to iterate over the archetypes per se. I want to iterate over the entities of an archetype within an area. So just all of the knights, right? I still want to support that thing. See, that one will be even easier. It's just a more slimmed down version of what we've already done. Typed IDs, though, I don't think they're going to be... You would save a bit of memory on the reference. Typed IDs could be used for some assertions though. Yeah, I think we'll want them. So the reference will never be typed. Maybe. Yeah, maybe we want them. Maybe they're useful. You get like they're strongly typed. That could be beneficial. Doing all the nicest dribble, the area thing. Yeah, exactly. Yeah, it's gonna be. Yeah, that's why I want to do this version first. Can we have an AOS variant? We can't do that anymore. We've designed the iteration API in a way that we can't switch between array of struts and structure of arrays, but that's fine. Yeah, I really wanted to see the numbers, but yeah. But we can definitely have optional swizzling turned on and off. But we'd have to have different. Wait, could we? No, I think we'll do. Yeah, I think we'll just swizzle by default. Could you turn it on and off? Yeah, we turned it on and off. We'll have to have different usage code. That's okay. Wait, yeah. Yeah, different usage code. You just use the entity refs. The code will look different though. Yeah. So we did the AOS version. We wouldn't be able to do this array approach. So we need to iterate over, and you get a full pointer back. Yeah, I don't want to write two different versions of code. That's cool. I'm really happy with this design though, because it opens the door for SIMD, which is what I wanted to do. And it's quite simple, right? I don't know if you've seen other entity component system APIs, and the way they do this and the iteration is like a lot more magic macro stuff because it's not codegen. Because with codegen this is a lot more elegant. So when I want to do a for loop, now I'll just copy and paste some code. I'll probably have an example laying around just so I can copy paste it and just get going every time I want to do a new iteration. Maybe there's ways we can clean up the API and make it a little bit nicer, but it's pretty good where it's at, I reckon. Fair play. I think it was when I saw it was the Flex C API. I think the one that I saw. But this one does dynamic data structures in yeah, so they're all made at runtime, so it's gonna have a bit of a more complicated API. There's a C API for it. I don't know, there's a way. Actually, maybe that isn't that bad. Wait, what is this? Right, so you register like, oh, let's register those components, then define a system, and then insert these things into the, and get back an entity pointer, and then I guess that will iterate. No, it doesn't iterate, does it? Yeah, I wonder what the iteration is in CAPI. I forgot it now. I was just making an entity, I think. But yeah. That's not bad, and we can iterate within an area. Cool. Right, I need to find someone to raid now because I need to eat some food. maybe exercise, watch some videos. But yeah, thanks for coming, everyone. It's good progress today. Tuesday and Thursdays when I'm next on at 7:30 p.m. GMT +1, and also Sunday 4 hours ago. But next week I'll also be on. But yeah, good progress today. I'm happy with the API and where we got it. Yeah, lots of work and frying brains, but it was good. Similar or smaller size, let's go. Right, I might just bail.